Today we're going to talk about adjacent angles. So we reviewed naming angles, measuring angles, classifying angles in the last lesson. Today we're going to move on to what we call adjacent angles. If two angles share a side and a vertex, then they are adjacent. Remember, the sides are the rays, and then the vertex is the point where the two rays come together. Okay? When I see this picture here, it's real easy to say there are three angles in this picture. I have angle SEU or UES. I'm going to color that one in blue. I have angle UEN, or I could call it angle NEU. I'm going to color this one in orange. Okay, and then I have angle NET, or I could call it TEN, either way, and I'm going to do this one in green. Okay, it's real tempting to say, oh, I could have put a box there because it's 90, but look, nowhere does it say that this picture is to scale. So even though this looks like it should be a right angle, and these two should be acute angles, there's nothing here that tells me that. So for all I know, this one is acute, and one of these are obtuse, one of these are acute. I know together they are making this line down here, so together they make a line, but I don't know how big any of them are, so I can't assume that one's 90. Okay? Now, it's easy to say I said that there are three angles there, but really there are more than that because I have some overlapping angles. I have UET or TEU is also an angle. Okay, and then I have angle on these two. When I put these two together, I have NES or SEN. This side is an angle that I'm going to mark in purple. And then last but not least, we would have the whole straight angle. I would have this whole thing, this whole straight angle. So really, I have 1, 2, 3, 4, 5, 6 angles in this one picture. Okay? All right, so we're going to decide whether or not the two angles given to us are adjacent or if they're non-adjacent. Okay? If they're adjacent, then they're going to share a side and a vertex. I can tell by looking that they share a vertex just by checking the letter on the center. So this one has an E in the middle, this one has an E in the middle, so they do share a vertex. Do they share a side? Okay, so to find that out, let's see, NET, that's my green angle, and it has rays of EN and ET. EN is one of its rays, and ET is the other ray. And sometimes I'll even kind of highlight them so I can see, because then I'll know. Okay, those are my two rays that go with the green angle. UEN was my orange angle. So that was my orange angle, UEN. So its rays are EU and EN. EU is one of its sides, and EN is one of its sides. So then I want to know, do they have a side in common? So look, EN, EN. So yes, these are adjacent, the orange and the green. Orange and green are sitting right next to each other. Okay, so then when I look at the next one, UEN, that's that orange one we just looked at. So I know its sides are already EU and EN. I already know that. TEU is the one that I marked with the pink. TEU is the one that I marked with the pink, and it has rays ET and EU. ET and EU are its sides. Okay, and you can actually tell by looking, EN and ET, EN and ET are this is rays. EU and EN are this one's rays. ET, and EU are this one's rays, or this one's sides. Okay, so now let's look at the orange and the pink. Here's the orange, here's the pink. Do they have a ray in common? Okay, so they do share a ray, but here's the thing, okay? This part right here is important. They may not overlap. So you see how this pink one goes over on top of the orange one? They're not allowed to do that. So even though they share this ray and they share this vertex, since these overlap, we have to say these are non-adjacent, okay, because they're not allowed to overlap. All right, let's look at the next one, UES, UES. So that's that blue angle, and its sides or its rays are EU, which I could see here, and ES, ES. Those are the blue angle's sides. And then UEN, UEN, so that's that orange one again. We're using the orange one a lot. That has EU and EN, so they both have EU. And then look at the orange and the blue. They're not overlapping, they are right next to each other. So we say yes, they are adjacent. Okay, and then the last one, NET. NET is the green angle. And SEU. SEU is the blue angle. So when I look at the green angle and the blue angle, they're not overlapping. But if I look, my green is EN and ET. My blue is EU and ES. So they don't have any rays in common. This orange one is stuck in the middle. So they're not adjacent. Adjacent means they have to be next to each other. The word adjacent means next to. So like right now, if you look to your right and there's something there, you're sitting adjacent to whatever that is, right? If you were in class and somebody was sitting in the the desk next to you, you would say you sit adjacent to that person. Unfortunately, we can't do that right now, right? There's no being adjacent right now. All right, so we have to have our space in between. These two are not adjacent because the orange angle is coming between them. Okay? So to be not, they're either overlapping or there's something coming between them. Okay? So the orange angle is in between. That's why this one's not. Okay? So that's why those are not adjacent. All right, so now that we know what an adjacent angle is, two angles that are right next to each other, they share a side, they don't overlap, they share an angle, we're going to learn the angle addition postulate. And it's very much like the segment addition postulate that said if I have two segments sitting next to each other, I can add one to the other, and that'll tell me how long the whole thing is. The angle addition postulate is essentially the same thing. If I have two angles sitting next to each other, one angle and another angle, and I add them together, then together it'll give me the whole angle. Okay? So if two angles are adjacent, so they're sharing a side, they're sharing a ray, they're sharing a vertex, and they do not overlap, then we can add their measures to find the total angle. So let me show you what that looks like. Okay? When I look at this picture, it says find the measure of angle KLM. So the first thing I like to do is figure out which angle is KLM. KLM. So that's this whole thing here. Kind of looks like 90, but that doesn't mean it is. It could be obtuse. It could be acute. I don't know until I do the math. But I'm trying to find out how big is that whole green angle. If KLB, so let's see, what is KLB? KLB is 26 degrees. So I'm going to put a 26 in there. Okay? And then MLB, so MLB, I'm going to do this one in purple, MLB, so this side right here is 60 degrees. Okay? So it wants to know what the whole thing is. My segment addition postulate says if two angles, the purple and the orange, share the vertex and they're sharing this ray, these two angles are right next to each other, then I can add them together to get the whole thing. So what that's saying is when I'm using my segment addition postulate, this angle that's on the bottom, KLB, the measure of angle KLB, plus the measure of angle, the one that's next to it, MLB, equals the whole angle KLM, the measure of angle KLM. So that right there is the segment addition postulate. Okay, so then I just fill it in. KLB is the orange angle, 26, plus MLB. MLB is the purple angle, 60. Together, that's going to equal the measure of angle KLM, my green angle. So then I just need to combine my like terms, and I can see that 86 degrees is the measure of angle KLM. Okay, so if this was a proof, I'd first have to say I have adjacent angles, so that I could use the adjacent angle, the angle addition postulate. Then I would have my givens, 26 degrees and 60 degrees. And then I could use my segment addition postulate, substitute in, combine like terms, and then if this was a proof, I would probably want to switch this around. The measure of angle LM is equal to 86 degrees using my symmetric property of equality. Okay? So we're going to practice a little bit with that in the next video, and we'll also do a full proof in the next video. So if you're struggling with proofs, you definitely want to watch the next video.